All right, guys. So in today's video, we are going to continue to talk about the distribution of difference of proportions. We've already seen that for significance tests. Now let's look at it in the context of confidence intervals and how they are slightly different. To begin with, it's worth pointing out that once again, while we would like to use standard deviation of p hat 1 minus p hat 2, we typically are not going to know the population parameters. Otherwise, there'd be no point in trying to estimate them. So we will typically be using standard error. So I've got both of those formulas here at the beginning of the notes. Remember that standard error of a difference of proportions, or in any case standard error, is the same as standard deviation, just using your sample value. So the standard error of p hat 1 minus p hat 2 is going to be that square root of p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. And then that'll be part of what we'll use in building our confidence interval. So remember that in a confidence interval, typically it is written as the statistic plus or minus your critical value multiplied by the standard deviation of the statistic. In this case, that is p hat 1 minus p hat 2 for the statistic, z star for our critical value, and then our standard deviation of the statistic there, which I'm not going to read all out. So let's go ahead and take a look at an example of this regarding gun control. So have opinions changed about gun control? Gallup regularly asked random samples of U.S. adults their opinions on a variety of issues. In a poll of 1,011 adults in January 2013, 38% responded that they were dissatisfied with the nation's gun laws and policies and want them to be stricter. In a similar poll of 1,011 adults in January of 2012, only 25% agreed with this statement. So in part A, explain why we should use a confidence interval to estimate the change in opinion, rather than just saying the percentage increased by 13%. And so when we're talking about kind of the difference between these two and why it would have increased from 2012 to 2013, we've got to make sure that we eliminate any sort of variation in our samples. So eliminating variation between samples is going to be why we want to build a confidence interval. In other words, it could have just been that the 1,011 U.S. adults they asked in 2013 were just more dissatisfied than those that were asked in 2012. Those are, by the way, not the same people, so it could have just been that the two samples had different people with different opinions. And so the interval is going to help us with deciding whether or not there actually is a difference between the two. So in order to do that, we're going to use the results of those polls to construct and interpret a confidence interval. We're going to use a 90% confidence level for the change in proportion of U.S. adults who would agree with the statement about gun laws. So in part one, let's make sure for our statement that we're saying our parameters of interest as well as the confidence level. So we're going to let P1 represent the true proportion. In 2000, we'll say 13, who would agree with the statement. And then we'll let P2 be the true proportion. In 2012, who would agree with the statement. And even though it tells us in the problem what level to use, we'll still go ahead and mention over here that our confidence level we plan to use is going to be that 90%. So there's going to be our statement. Now let's go ahead and do our plan step. So in our plan step, first we're going to say what type of test we are doing. In this case, this is a two proportion Z interval. And then we'll go ahead and check our conditions here. First of all, are both of these coming from a random sample? And it does say up here that they ask random samples and that both of the studies were similar. So yes, we could go ahead and say that they are random. Next, we'll check 10% conditions. So take 10 multiplied by 1,011 is 1,000, or 10,000 rather, 110. Is it reasonable to assume they could have asked that many adults or more? And I would say yes. Here's the kicker, is even though it's the exact same number, we still have to write it again. And it would probably be best to use some notation here to distinguish these. We'll call this capital N1, capital N2. That way we know that we are checking that against our samples or our population size for each of those two respective years. And then last but not least, and this is the one that will probably take the longest, is our 10% or our large counts condition. So we'll first take 1011 multiplied by the 0.38 in that first sample. So 1011 multiplied by 0.38 is going to be 384. I'll just round down there since it wouldn't have been a 0.18 of a person. So 384 there is clearly greater than or equal to 10. 1011 multiplied by 0.62 then is going to give us 627. Again, I'll round that up, which is also greater than or equal to 10. Now I need to check that for my second sample where it was only 25%. So 1011 multiplied by 0.25 is going to be 253, which is greater than or equal to 10. And last but not least, 1011 multiplied by 0.75 is 758. Is that also greater than or equal to 10? And it is. So large counts condition is met for both of these two samples. Okay, so after all of that, we can now go ahead and start to do our calculations for our interval. So for our interval, we're going to start with finding our parameter here for our beginning, our point estimate rather. So in this first part, we're going to take our 0.38, which was for our first sample, minus our 0.25, which was for our second sample, plus and minus our critical value. So we need to figure out our critical value here. Keep in mind this is a 95% or a 90% confidence level. So if I want to do my inverse norm, area to the left is 0.05 for me. It would be 0.9 if you're choosing center. Mean and standard deviation, 0 and 1, is going to be 1.645 for both positive and negative of that. So 1.645 there as our critical value Z star. And now we need to get our standard error. I'm going to zoom in a little bit to make that easier to read. And that's going to be where we're taking 0.38 times 0.62 over 1011 plus our 0.25 times 0.75 also over 1011. And then to simplify this interval, we'll go ahead and then put it into our calculator. First of all, 0.38 minus 0.25 would be equal to 0.13. So there would be our point estimate for our difference in the proportions. And then we're going to take that minus our critical value, so plus the negative of that, times the square root of, we're going to be taking 0.38 times 0.62 divided by 1011 plus now the 0.25 times 0.75 also over 1011, close our parentheses, and here's going to be the lower end of that confidence interval, so 0.096 up to, and then all we have to then do is take 0.13 minus, or plus all that rather. So I'll just go in and change that from the answer to be 0.13 plus that value. And that's going to give me the upper end of my confidence interval, which is 0.164. There would be my two ends of my confidence interval. So last in step 4, let's go ahead and interpret that now. So what we're going to say is that we are 90% confident that the interval from 0.096 to 0.164 captures the true difference in proportions of adults who agree with the statement going from 2013 to 2012. So again, make sure you mention what order that you do that in. So then based on our interval, is there convincing evidence now that the opinions about gun control have changed Well, let's think about if they haven't changed first. If there hasn't been a change, then there would be no difference between the two proportions. So no difference would be essentially asking, is 0 contained in the interval or not? Because if it is, then there is that chance that they haven't changed, that maybe the difference is just due to slight variation. But if 0 is not within the interval, then the answer is going to be yes, opinions have changed. So yes, opinions have most likely changed because 0 is not in our interval. All right, guys, that's going to be it for this video. The next example, by the way, is what we will use as our warm-up for our next class period. So make sure that you have that ready to go. And if you want to look at it ahead of time, feel free to do that. But that's how we will start our next class. We'll be talking about that example problem. Until then, have a good rest of your day.